So I don't know. So Pavlo just wanted to everybody to answer what the hell is big data. I don't know. I've mostly my encounter with this question is very much very mixed, because when I go to, I've done a bunch of work with NoSQL data stores and kind of conversational state and systems, not really analytics stuff. But often when I go to a customer site and they want to hear something about NoSQL, what they really want to hear is about analytics and open source analytics, for instance. So there's a lot of confusion. People don't know what they want, and they don't know what's out there really. So I think really we need somebody to do landscapes for this entire new space, right? So maybe we could start by each introducing how do you see the landscape? I don't know. Somebody has comments on that?
Sure.
Has anyone here heard of the 4 V's of big data? You know, volume, velocity. That's horseshit. No, big data has nothing to do with volume, velocity, you know, how big your phallus is or anything like this. Big data is very, very simple. It's like everything else. We're technical, so we're what and we're how people. We like to figure things out. Big data is about why. It's about value. What are the implications of doing something, and what are the implications of not doing something? It's about insight. And the timeliness or relevance of this is where big data starts. So it's trying to adapt technologies to your needs right now in the time frames that are important to you. So for me, that's what big data is about. Technology is a secondary concern.
Sure, I'll take a shot. So I do a lot of consulting in the Hadoop space, and of course big data is a marketing term, right? And it means that the suits are throwing money at it. But when I tell people what I think it means, I mean literally that's, it's where the money is right now. I tell them that it's basically data that's big enough that it's become unwieldy with traditional technologies, or maybe it's too expensive. We have customers who can fit everything in their Oracle databases or their Teradata warehouses, but they're tired of paying $1 million, which is still a lot of money in the U.S. At these big systems, so they want something cheaper, so they'll go to these alternative technologies, and then that brings up all of these other things that nobody understands, like the NoSQL databases and what are they actually solving? Do I actually need them? So the other problem I run into is customers know or think they should be on this bandwagon, but actually they have no idea what it means, and in fact they often don't have data that's so big that they have to use these alternatives. And people forget that we only gave up transactions and SQL because we felt we had to, and now we're seeing a trend towards putting all that back in. Like Google has got these, as you mentioned in our intro this morning, these they're building distributed transactional systems again. All of the NoSQL stores have some sort of query language now, or at least they're adding them. So we're kind of going full circle, like we always tend to do in technology. Next question.
Next question. I don't think you really answered my question, any of you. I mean, what is the landscape? I mean, what are the kinds of what people really want to know is what are the kinds of data stores out there, isn't it?
Well, I think that it's not only about data stores, but actually, I agree with you, Dean, that I also do this big data consulting. I think that what we first need is to sort out different business cases. What are the business cases for big data? How can we help with this hype, with this stupid 2 words? How can we help really improve companies? I've been talking about changing the world and stuff, but anyway, when we concern the companies, it's all about gaining information out of nothing. So if you don't have data, you need to produce data, you need to buy data to get it into data stores, actually. But at some point, when you go to a company and says, I'm a big data expert, the most interesting thing you can tell them is, I can show you 20 business cases. And business cases are, for example, saving money. That's what you told. Like using NoSQL data stores, open source software and so on and so forth. Or, for example, where to get data for analytics, how to use Hadoop in order to replace huge IBM whatever series, where they pay like gazillions of dollars for just a small performance booth. So I think that before we make a landscape, we need to clearly name the business cases at all. Because when we don't do this, it will be only one. How can I save money using NoSQL data stores? Actually, this is what I experience, and I think it's stupid, but this is the first question I'm getting asked right now.
Also maybe the confusion that a lot of companies, they think in one solution, so they think let's have a huge. So maybe a lot of companies they think in solutions where they have one store, one database that will solve the whole problem. Whereas to me it seems more like big data is kind of facilitating a process to analyze your data. And there's this new thing, Netisa or something like that. It's called, I think. Yeah. So it's huh? It's not new anymore. Well, I just heard about it a couple of months ago. That all seems like a very big solution, very expensive, to deal with this big data thing. Whereas probably a simple system like Hadoop or Disco could do the same job, much more cheap.
So I think you brought up a good point about what are the actual scenarios. So one of them is of course size, but you know, for most of the companies I deal with, if they're doing just traditional analytics or they're capturing sales on the store or whatever, unless you're Amazon or Google, you can probably still do it in your Oracles, MySQLs, and so forth, and you still have those rich tools for reporting and all the usual stuff we like to have. But it's some of these new scenarios that Pavlo was talking about in his last talk that are also driving a lot of this interest, like can I mine Twitter to find out what people are saying about my company or to understand what market niches exist that I don't know about. And those kinds of things are where you get into not only the problem of the relational stores aren't designed for doing like natural language processing or other kinds of machine learning, and that brings in additional processing requirements that have led to MapReduce and so forth. But also the kind of data that you're storing is now not what you traditionally think of as useful for a relational store, like raw text for twits. In some cases that's the case. For tweets that you want to somehow do this natural language processing on. So you need a lot more flexibility now for processing the data. And if you really do have a lot of data, if you are lucky enough to be a Twitter or Facebook or whatever, then you have to have some way of storing it in a cost-effective way. Just a little factoid. Facebook has something like 600 petabytes of data now in Hadoop clusters. And by the way, you cannot put that much data in one Hadoop cluster. There are all kinds of limitations to how much you can actually store in a single cluster. But so obviously they have the real problems that are driving the innovation that the rest of us are kind of spoon-feeding off of.
Probably you have an opinion about storing data.
I think it's also interesting how the canonical big data example is web scale, right? It's Facebook or Google. I'm a small, fast data guy. I build gambling and trading systems. I don't hit disk. It's slow. Even solid-state disk is slow relative to not hitting disk at all. Hitting level 3 cache is painful enough. And when you're building those kinds of systems, it changes the way you think of the world, right? Different context, different environment. The first principles, the trade-offs and nuances kind of are inverted from the typical case. So let me give you an example. How many messages per second in North America, so Canada and the United States, are they sending per second during market open in equities and options? It's like about 19 different exchanges. 3 million a second on average. But they're only about 50 bytes, right? It's not a 1K document. So would you use HTTP for this? No, there's about a 1K overhead and headers, protocol and so on. They use efficient packed binary protocols. So if you take the currency markets, so trading sterling, dollars, stuff like that. That's about a 1K document, but you might get a 100 microsecond kind of latency profile for something like this. And then you look at something like Draw Something, which OMG Pop came out recently. It was quite a big kind of Couchbase story. They grew from, I think, 3 to 90 boxes in the first 6 weeks. It was quite successful. Then didn't Zynga buy OMG Pop, and then it wasn't successful? I don't know, something like that. But they have, I reckon those vector drawings are about a 10K document, right? But they have a 1 millisecond time frame. So size, speed, we're moving away from value here. It's about what are the implications, what insights, what business intelligence, what advantage can I gain, or what costs can I reduce through processing data, whether it's in flight or on disk. I don't think that matters. And the tools we choose are really dependent on those decisions. If it's already hit disk, well, use Hadoop, it's fine. If it hasn't hit disk yet, process it in flight, reduce the amount of data you need to store to disk. So sometimes it's about the data and qualities of service around that data in flight, and sometimes it's not. You've already stored this data, so it's about further leverage after the fact. So use the right tool for the job is really where, and think about using the right tool for the job is where big data starts, compared to older techniques. That was, oh, we'll just use the Oracle database. Because that was always the answer, so asking the question is irrelevant, right? Big data is about asking those questions, because now they're relevant.
Just to add to this best tool for the job, when I'm going to a customer and I hear the first question is like, can you compare MongoDB with Hadoop? I'm like, okay, I need a story for that. Seriously, it's necessary. It's a lot of confusion around this hype word. So I think a landscape business case is a combination of that. You're absolutely right with that. Somebody has to define it. I mean, actually, probably I still can use some of these thoughts in my book, which will come out in January, but it's German, so it's like 400 people to read it.
I'll just throw in one other factoid that kind of ties the two together. The Large Hadron Collider at CERN that just discovered the Higgs boson this year, it generates something like, I think it's a petabyte of data every hour or some number like that. And of course you can't actually, there's no network that can actually distribute that much data at once. So they actually do a lot of the filtering of the signal in hardware and those massive detectors you've seen pictures of. And so it's reduced by many orders of magnitude by the time the interesting data gets out to the computer networks that are going around the world. So, yes. But they're not using Hadoop for that either, of course.
No. But they also have to adjust magnets when the moon is straight over this thing.
Yeah.
Even when a train goes by.
Yeah, trains going by the moon. Yeah.
Exactly.
Yeah, we had the maestro of data coming to GoTo in Aarhus a couple of months ago, talking about that entire system. It's really amazing. But it kind of dwarfs the rest of us in terms of data needs. We're just building, maybe medium to large scale business applications, and I think see lots of people misstepping into using these technologies, even though they don't need to, or they want to try something new, and it's kind of encouraging for the employees and blah blah blah. But it's kind of one of the more interesting comments on this was we had a panel like this at GoTo recently, and Pavlo was on the panel, and he said, the basic rule is don't use any of this, you really don't want to encourage everybody to go out and pick up NoSQL stores and big data things unless they really have to know what they're doing. And you often see people experimenting with this and wasting whole boatloads of time and money on playing with this when they don't really get any value out of it. That was kind of an interesting comment from there. I don't know if you've seen stories of something like this.
Yeah, actually one of the things I recommend to clients is just get on Amazon and use their Hadoop ecosystem for a while to understand it, because it's relatively cheap and you're not making this big commitment in a huge cluster that's going to sit idle when you realize it's not what you actually need. But I think that's a great comment that Martin made, that a lot of times you should be skeptical of things and convince yourself through business cases that this is actually solving a problem I really have, and not just something to make the engineers have something new to play with, but as much as we all like to do that. But yeah.
So maybe there's some questions from the audience. Anybody?
So you say maybe we shouldn't use these technologies for small data, but in some settings, couldn't it make sense to use something like Riak or where you have like very distributed data? Because in the traditional world, you could like create an SQL server that has slaves, a master and some slaves, and there that's also kind of eventually consistent anyway. So maybe some of the NoSQL databases will actually fit your data models and your usages without being big data. Does that make sense? Go ahead.
Also speaking of stories, it's one example to answer your question. I was on a project. It was called Big Data, and I quickly realized that this big data is like 4 GB big, and I can put it on my flash memory. But anyway, the problem there was that they had like 20 different, absolutely different data sources. The data came from absolutely different things, and you had to formalize this in a way to normalize this, to have one representation for one single feature. And they also expected this part of the system to scale up to 20 million requests per second. So it's 4 gig of data, actually, but it's a scalability request like, wow. So go find technologies for that. So you start with C10K and then so on and so forth, just to scale far. And the whole stack, the big data stack, will include tools like that. It's not only storage, it's everything. It's just there are technologies around who will allow you to go that far.
Yeah, that's an interesting point. So I was going to talk about this afternoon in my talk, that one of the trends that's driving a lot of this is that you do have to integrate a lot of different data sources that are sometimes evolving rapidly. So spending a lot of time doing data modeling in the way we used to do actually just doesn't pay the same dividends it used to pay, because it's going to change anyway, so you just have to be adaptable. And in fact, Rich Hickey mentioned this yesterday about thinking about associative stores or associative data structures, basically, maps of key values, that working with those is a much more flexible approach. I think the other factor that led into things like Riak and why they're important versus, say, Oracle and MySQL is the CAP theorem, which many of you may have heard of, which is consistency, availability versus partition tolerance. It's basically pick 2, although really what it means is if you get a partition in your network, so that now that I've got a couple of these shards that are no longer connected, do I give up availability so that I'm absolutely consistent at all times when somebody talks to any part of the system, or do I give up see, I guess I said that already. If I give up availability, then I'm consistent. But if I really want to be available, then maybe I tolerate inconsistencies or eventual consistency. And for me, one of the great examples is the Amazon catalog. If I go shopping on Amazon, they're willing to show me a stale catalog rather than not show me anything, and they'll fix up any problems. Like if I buy something that actually is out of stock, that's okay. That's a problem that's solvable. So that's another factor that's driving this. And to what Pavlo said a second ago, I had a customer recently that they could do everything they needed to do with their data in SAS except one thing, which was a big machine learning algorithm they ran on this data for marketing purposes. And this is a very classic scenario. They would take the data, import it into Hadoop to run this algorithm in 1/10 the time, and then export the results back into SAS because they had all that mature tooling that they understood and so forth. So that's the other part of it. Nobody just throws away their old stuff. They just bring in more stuff that they have to work with and manage and figure out how to integrate. Yeah.
But it is an interesting question. So one of the great things about the database community recently is you're seeing lots of these different, more niche, specialized databases coming out. So I'm kind of cap markets-y, kind of finance. So what do they use in cap markets? Well, they do a lot of time series processing. So they use Cassandra. It's what you use if you want a good time series kind of data store. Although if you go deeper within capital markets, they have databases that the regular community has never heard of. Has anyone heard of the K or Q programming languages? A few weird people like us, some of you. But these are data parallel programming languages like MATLAB or Mathematica. There's Julia, which is a pretty cool new language coming out. So there's a lot of specialization. There's the value, they're called tick stores. They're not even called databases because they have a very fine-grained notion of time, much in the same way that Datomic does, right? It allows you to zoom into the past. But these typically allow you to zoom into the past, but also in a forensically auditable way. So they have two notions of time. When you store data and then when you mutated it. So it does tend to further and further specialize as your needs become more and more fine-grained. The more you know what you know, the less everything kind of fits the model, the shape that you're trying to fit things into. So the simple versus easy or decomplecting notions that Rich Hickey has, just think that way, because he's got it right.
Yeah, we had a use case where these completely different requirements also went into play when we picked a NoSQL store. It was exactly the cap stuff. We needed these systems to be able to operate completely if they're isolated, being able to do updates and record information, and it was perfectly okay to continue operating on old data, which was eventually consistent. Of course, it meant you have to deal with all these potential conflicts, but that's just the value it added was so much bigger that was really the interesting case. So it's not necessarily even a business case, but it wasn't in terms of making it cheaper. It was just making that actually possible, and this wasn't really a big data case. It's very manageable data sizes, but just being able to manage offline data and synchronization and stuff like that for medium-scale projects, but critical projects, was a completely different case.
Probably we need some effort in the community to change this term. I mean, big data doesn't say anything. You can't even sell this because yeah, yes, you can. Of course, you can. Yeah, well, I mean,
But no one else can. That's yours.
Yes, exactly.
We have a company called Think Big Analytics.
There we go.
Yeah, awesome. Okay, no, you know what I mean. It doesn't say anything. So I also don't think that it's possible to have one term for everything there. So I'm absolutely with Kresten here to define a landscape, to define also the business cases and so on, like a catalog. Just pick, well, as simple as cap. I mean, simple is one of the most difficult things you can buy, but anyway, just simple as this. Pick 2 or 3 out of something based on your business case, based on your needs, and we also need community effort to help potential customers recognize new business cases. And I think this is very important. This development that there is a profession called data scientist, and I'm absolutely in love with this profession. It's like 25 years too late for me to become data scientist, but anyway, I'm doing my best to recall all these things. But still, it's a profession where a guy goes into a company and tries to define new ways to gain information out of data. And when he says that we don't have this data, we need to get this data somewhere. We need to produce logs. We need to buy it by data sift, whatever it is. And somebody who just pushes it and analyzes the whole existing MDMs and you name them. It's I think it's also absolutely necessary to combine these approaches with classic BI tools, with everything, just to have a map of things that an enterprise can win out of data, information, useful information.
I think everyone's seen the film Jerry Maguire, right? I think we should call it Quan data, right? It's not just the money, right?
Cool.
We should call it Quan data, right? Because it's about gaining value, gaining insight, understanding implications. It's not about volume, velocity, that's vacuous, vomitous. It's not about any of these things, right? It literally is try and understand, and sometimes that's an algorithm problem, sometimes a data problem, sometimes it's a technology problem. A lot of the times today, especially web scale, because that's the canonical issue, it's a people problem, right? It's machine to human, right? So Twitter's been really, really successful. Everyone uses it. We rant on it all the time. What's the most annoying thing about Twitter? Whoops, you already said that. No, I didn't. You just said I already said that, but I didn't. And then, so you go, well, it didn't actually get that. So I'll send it again. It says, no, we've already have that. But you just said, hang on, that's wrong. It's immediately inconsistent, right? And it's these things which are a problem for humans. But eventually consistent, maybe, right? It's these systems. And it's these, I call them eye beckons. You know, the problem is the bird. Just look at the bird. It's so successful because it's really useful. It's the small niggling things we need to fix. It's like you go to a conference and you're at a demo and someone does an awesome demo where they spin up like 200 Amazon web machines to process 2 gigs of data. And you go, but you've got a solid state drive in your machine. You can process this in a few seconds with grep. Why did you even bother with the demo? I look at these demos and go, it's not about spinning up machines. It's about processing that data. And trust me, you can do that on your hard drive with awk and it'll be done. And it's really simple. It's about relevance, right? Relevance. And being able to spin up a couple of hundred machines with the JClouds API might be fun, but it sure as hell ain't relevant. And big data is about quan, not big, right? The big is just the wrong word. And I think everyone's getting caught up on it. So just tell them they're wrong.
Yeah, I think there's an interesting gap right now, but as far as tooling and need for end users between the really big stuff, which we kind of have more or less reasonably nailed with MapReduce, if as flawed as it is, as I'll discuss later. But there's a smaller data set, and then how do I make that, how do I let the average data analyst who only knows SQL do analytics and ask the big questions and experiment and understand what he's seeing and so forth? That is a huge problem. There's actually a big opportunity, I think, right there for not only addressing the medium-sized data sizes, but also making this stuff accessible to people who aren't, you know, geeks like us. In fact, I think actually I co-wrote a book on this SQL language called Hive for MapReduce, and I'm not really a SQL guy, but this is so important, this tool, and it didn't have documentation, that I felt that it was essential to get more documentation out there, so kind of jumping on it for that reason.
Awesome. Do you have questions, guys? I need to force it.
What does big data mean to you?
Yeah, just go on. You asked me about Twitter earlier, so.
Yeah, well,
Would you like?
I have to think about it.
Okay, here you go.
Can I ask a question? I agree completely with what you said about big data not being about actual volumes and sizes of files and what have you. But there is a perception with less technical people that it is about this. So when people are working with data and it gets to a specific size, they think, okay, we might have to start looking at alternative solutions now. And I think roughly that's kind of when you get to terabytes, people start to think like this. But I think in the next few years, I mean, that will become more commonplace to be generating like a terabyte of data. So how do you see it progressing? Like, what will be the point at which people will think, okay, let's look at something else?
Well, I think we'll start seeing a couple of different kinds of things being adopted as kind of standard technologies, and that kind of alleviated. Like having a KV store is going to probably be part of standard infrastructure. Just like everybody has some kind of SQL database in their standard infrastructure, everybody's going to have a KV store, and that's going to be that's an example of an easy point where you can easily. We've gone in also to customers and have had big, expensive Oracle installations and said, well, basically you can reduce your data size by putting 60% or 80% of your data into KV stores because that's the way you're accessing it anyway. And then leave the indexing and whatever needed for ad hoc querying. Maybe you can put all maybe they're putting media or something else in Oracle stores, and we can basically, there's a very straightforward business case for just putting number of bytes somewhere else where it's less expensive, a number of transactions or whatnot. So there's like KV stores, and there's probably also other, you can imagine, time series stores, various kinds of stores that are probably going to come in as part of standard infrastructure. And I think I think we will see that more than actually a cutoff for where does big data start. people starting to understand, these various things, and starting to use it more comfortably, instead of today, as you said several times, that you imagine that you have to put everything into one kind of database right now, right?
Yeah, I said earlier that sometimes I have clients who really don't need Hadoop yet, but they think they need to jump on the bandwagon. And certainly the counter argument is, well, they're probably going to need it eventually, or technologies like that. And so sort of greasing the skids, as it were, to be aware of this stuff is certainly something worth doing. And one of the things I think that's great about all of this stuff is that it's kind of forcing people to think flexibly and to learn how to build componentized systems that glue together well, and so they can build what they need today and adapt and grow, whereas some of the more traditional data technologies were a little more monolithic, a little bit more resistant to change, and so a lot of this stuff will kind of force this kind of change in thinking that's going to have to happen for people to be able to adapt to these larger data sets, but hopefully not do it too soon, but only on demand, I think.
Can I? Just to name it, I think that, speaking of distributed data stores, and I think that we all agree on the fact that huge amounts of data that can grow, and they probably, if you go for the atomic and things like that, they will probably be always there. You will not even delete anything there. So this will grow and grow. Well, it's the uncertain part of it, but anyway, what I mean is that I think that this classic master data management systems, I'm not sure you're aware of these systems. It's like the typical enterprise problem, having an MDM in the enterprise. It's there to collect from all the different data stores they have picked all over the years, like 20 different databases, RDBMSs. Because of contracts, because of whatever. I mean, there are enterprises as big as whole huge countries, right? So anyway, this MDM, and I think this development will go in this direction. People are already discussing HDFS behind Hadoop as the future of MDM. I think it's not only this one. I think it's also, there is plenty of room for React, for systems like that. That will just go into this direction, and it also will go in a way into this cloudy thing, right? Because for some different reasons, it's not very simple to have public clouds for in Germany. So in Germany they go for data protection reasons. They go for private clouds, but still it's clouds. It's about elastic solutions. That's what I mean with that, and it will grow and grow and grow and grow, and it has potential with the stores we have now, with the technologies we have now, to replace the classic, fat, customizable for lots of money MDM solutions. Because just look at that couch, just look at the React, which is one level deeper, lower. It can take anything as value. So you are absolutely not depending on the representation on the other side. You can pull it together, you can put it together in one data store. You can have schemas, everyday schema, second schema. Like at this second, we had this schema in the enterprise. It's difficult to discuss this with enterprise architects. This is a big problem because the only reason for them to exist is to maintain data models in the companies. I think the data model has gone. You will have to have a data model in your application. You need to have an understanding for that, but it's not about storage. You need to pick technologies to store anything. This is the point, and I think that this will go into this direction, and it doesn't matter if it's HDFS, if it's React, whatever. It's similar approaches.
And luckily, it's really simple to detect if you have a big data opportunity in your organization. Are you suffering a lot of pain? You've got a big data problem. It's that simple. We don't know what it is, but we know what it feels like. I mean, so you've got a data problem that's too big or it's the wrong shape. It's a big data problem. And as you have more diversity in communication systems and storage systems and analytics platforms, you'll find that you can compose these better to suit your particular shape or type or size of problem. And I think that's the kind of revolution we're seeing, is that people are going, I'm suffering, so I'm going to do a different kind of database. So that creates a Datomic and a React and a this and a that. And people are going, I'm no longer using what everyone else uses because my problem is different. So I'm going to approach the solution in a way that suits the needs of my problem. So I think we're wising up. So I think over the next 10 years, most of the disruptive companies will do it the right way for them, and just go, that's the way we're doing it. If you have the same problem, use that. I think we'll be using simpler systems, and we'll be composing them a lot better. So again, I think a lot of the structural shaping talk that Rich Hickey does speaks directly to this. And I think that's the definitive trend, whether it's big data, quant data, small data, it doesn't matter. Right? It's all moving in that direction. We're moving away from the pain now. I think computer science is about to mature. We're getting good at it almost.
You reminded me, I think that one of the reasons, obviously, that functional programming has become so popular after decades of academic oblivion or whatever, is because it really is kind of the killer app, or this big data stuff is kind of the killer app for it. Just the recognition that being more flexible about data schema also means being flexible about object models, and maybe they don't make as much sense as everything's just in a big collection, and I just need to process this collection with standard tools like my maps and my group bys and filters and folds and stuff like that. So I kind of see this as sort of driving that evolution away from object-oriented languages, at least for these kinds of problems, towards your Erlangs, your Scalas, your Haskells, and so forth.
Yeah, I think we should probably close up pretty soon. I don't know if you're. There's an interesting thing that's kind of popped up a couple of times, is that these whoever is in charge of data currently in many enterprises are they're sitting on these MDMs, monolithic systems. I mean, how are we gonna? What is the transition? I mean, what's the transition we need to kind of loosen up those organizations and make them a proactive part in making the transition to a more kind of decomposed, system-oriented architecture rather than this monolithic, put an MDM or a big data store in the center of things? How do we get there?
I've started to create a strategy for that. Because I'm in the consulting company, so we actually need to sell stuff in a technological way. So the strategy is, I used to be enterprise architect on my own, so I know the pains, I know how people think. The point here is that when you manage to do what Darach mentioned, like having a zoo of technologies, which has to be managed, to put in tool chains, to test it adequately and stuff like that, right? There is still a reason for the same people to exist. And you still need those positions, you still need those roles in the companies, because if it grows big enough, have millions of applications in your company, somebody has to track this all, right?
You need a schema police.
Exactly, a schema police, but the schema police is not restrictive anymore, saying we need 3 months to check if this application expecting the overall enterprise model to get extended, if it's okay, if it doesn't break the rest or whatever, just put it into your store there and then access it later. They just need to track technologies, tools, licenses, whatever.
So in terms of that data guy inside the organization and his increasing migraine, nightmare, headache with the expectations we have out of data now, which are becoming increasingly sophisticated, none of us in this room at this conference will solve that problem. Right? The people who are going to solve this problem are the data visualization guys in the New York Times, in The Guardian, who are coming up with awesome ways to understand data simply, to take complex statistics so that you just understand it. It makes sense. It's the right size and shape. I think those people will drive more innovation around the technology that supports it than technologists ourselves, because it's about understanding, it's about implication, it's about value, it's about business. It's got diddly squat to do with technology. Because big data is really about big business, it's about big money. It's about value. It's about relevance. So I think they're going to drive more innovation than we will. We'll just bumble along as we always have, going, yeah, we're awesome now. But I really think it's these really high-value visualizations. So there's this D3.js kind of a guy in Square wrote. People are coming up with awesome ways to visualize, to drill into, and to extract value from data. And I think that will drive a lot of our expectations in terms of how we can interact with it. And those interactions will dictate the compositions of the systems based on the components we build, and the more sophisticated they get, the more reuse we want, so it drives towards smaller, simpler, more composable systems. And I think that's going to be the trend. Like, we're just going to react. Everyone else will dictate that.
Yeah, the other way that this will happen is sort of the way Erlang's kind of its story within Ericsson is sometimes these things start as skunkwork projects, or one team just has to use like React, and they can't just use the canonical Oracle blessed data store, and it'll kind of grow from there, and eventually higher ups in the company will realize this is what we need to be doing more globally, and it'll kind of infect the rest of the organization. So I think you'll see that as well, but I think it's a great point that when people see things like the New York Times visualizations or the Guardian, it just, the light bulbs kind of explode or something in your head, and they know they have to be doing something to address that need.
Well, yeah, another reason why focusing on value is also that's what's visible to senior management also, right? I mean, because these kind of radical changes typically have to come top down through organizations.
And if it's not, you need new management.
Yeah. Okay, I think we have to close up here. There's lunch coming on, so I think we could probably go on and discuss this forever. But we could take some discussions offline if there are more questions, I think. But let's say thank you to each other. Thank you.